Page 73, graphing linear equations. Again, we're doing this section out of Ed Ready's order, so watch your homework, make sure you're doing the right thing. A linear relationship graphs a line, right? The word line is in there. We can represent it with a table, a graph, and or an equation. We have standard form, which isn't really the best name for something because it's not the standard form as far as I'm concerned. We more typically use slope-intercept form. But standard form is called standard form. AX plus BY equals C. Slope-intercept form, that's what we're used to. Y equals MX plus B. And then for a horizontal line, we decided that the Y coordinate was constant. So it's Y equals some constant, I'll call it C. And for a vertical line, X is constant. We're going to look at 3 different ways to graph lines. And typically, you may be asked to graph in a particular way or all 3 ways, and then just make sure that your answers match up. So it's a built-in way to check your work. So we can start by graphing a table. We'll make a 4-column table, and I'll show you what that looks like. And we get to choose a value for X. This 1 is a footnote. It is not an exponent or a subscript. Notice that it says at the bottom of the page that sometimes it's helpful to solve for Y and then substitute values in. Other times you just sub values in without having to solve for Y first. That's whatever seems easiest. I generally solve for Y and then choose values of X, but you don't have to. Once we've chosen the value for X, we're going to substitute it into your equation to see what the Y value is. Then we plot the ordered pair that we just found, the X comma Y. And keep going until you have at least 3 ordered pairs to graph. Technically, 2 points determines a line, but if you have 3 and they're all on the same line, you're a little more confident in your answer. Once you have those points, draw a line through the points you plotted. Or we can put it in slope-intercept form. Now we have to solve for Y. Identify the Y-intercept of the point. Remember, that's where it crosses the Y-axis. And plot the point 0, comma, B, where B is that Y coordinate of the Y-intercept. Then we're going to use the slope to graph additional points from the Y-intercept. And there's a little trick that I like to use. I like to use the slope in kind of a weird way. And I'll show you what I mean by that. But sometimes I write the slope as, for example, 2/3. Sometimes I write it as -2 over -3. You'll see why when we graph. But for now, we're just giving the basics. Use the slope, draw some points, draw a line. And again, we want additional points. So that's at least 2 more, at least 3 points total. Or we can graph the X-intercept and the Y-intercept and connect them. This is the only one where we only have 2 points. The X-intercept is the point X comma 0, where the line intersects the X-axis. To find this point, substitute. What do you think we might substitute in? Well, X we don't know, but I know Y is supposed to be 0. Let's substitute 0 in for Y and solve for X. Then plot the X-intercept. The Y-intercept is similar. 0, comma Y, or we could call it 0, comma B. It means the same thing, right? Where the line intersects the Y-axis. To find this, substitute 0 in for X and solve for Y. Plot that point and then connect them. Draw a line through those 2 points. You got the 2 intercepts correct, and you can draw a line through those 2 points, you're good. So let's practice. Let's use all three methods. And actually, I apologize. Just look at my paper. Let's go back to page 73. We have a little bit of space here. I want to show you an example of a 4-column chart. Originally, I had this just in here for other instructors who might want it, but it's a good idea to see it yourself as well. X, the equation, Y, and XY. This is what I mean by a 4-column chart. So for example, if I plug in, if I have the equation y equals 3x plus 2, I might plug in a value for x. I tend to start with 0 because that's usually pretty easy. Not always, but usually. Plug it in, I have y equals 3 times 0 plus 2. So y is 0 plus 2, which is 2. My ordered pair is 0, 2. And then I can just keep going. So I'm finding ordered pairs that match up with that equation. Okay, now that we've seen a 4-column chart, let's build one for this next equation. We're going slow today. Okay, y equals 1.5x. So, first way is to build a chart. Sometimes I abbreviate equation EQN, but I still like to leave some space for it because sometimes the equation is a little longer. XY. So again, notice that where I draw my lines, I give a lot of space for the equation, not as much for x and y. So let's try 0. I have y equals 1.5 times 0. Well, anything times 0 is 0. So I have the point 0, 0, the origin. The origin is on this line. Let's plot that while we're at it. Okay. And let's switch to a different color for our next point. 1.5x. I noticed that if I put in an odd number, I'm going to have a decimal, which is okay, but I'd rather make it work out nicely. I'm going to use even numbers. So I'm going to try 2. Whoops. Okay, yeah, y equals 1.5 times 2, which is, well, we have 1.5 times 2, so that's 3. 0.2 comma 3 is on here. Over 2, up 3. Should probably label these. And let's do another point. Let's try, how about 6? Y equals 1.5. This one point a little bigger, times 6, which is 9. 6 comma 9. I go to plot that and it doesn't fit on my graph. So what I generally do is I say, okay, well, let's just do another point that does fit on the graph. We can extend the graph, but then it gets kind of messy. So I tend to just say, okay, that was great. Let's try something else. Let's try, so this is not on graph. Let's try -4. We can use negatives if we want. Maybe. There we go. Okay, -4. So y equals 1.5 times -4. So this is -6. And I have the point -4, -6. That's going to fit on my graph. -4. So left 4, down 6. I have a point right here. And yes, those do look like a straight line. Let's draw a straight line between them. We have something like this. We'll put arrows on both ends because it continues going in either direction. And notice that 6, 9, it wasn't on the graph, but it looks like it could be if we extended it. So that's a good sign. Okay, so that's method 1. Let's try method 2. Method 1 is, in my mind, the simplest, but also the most work. I would argue that it's the easiest one to understand. You're just picking out X and figuring out where Y is. But, you know, it takes up some space and so on. So an advantage of method 2 is we just start at the Y-intercept. So my Y-intercept is 0, B. Well, what's B? Y equals mx plus b, right? But we don't have a plus anything. Pause the video if you want for a moment to think about it. And you might come up with the fact that b is 0, right? I can add nothing. So my y-intercept is 0, 0, the origin. That won't always be the case, but that's the case for this one. And then I'm going to use my slope. My slope is, I read it off of here, 1.5. I don't want a decimal as my slope. I'd rather a fraction, an improper fraction. This is 1.5, so 3 halves. My slope is 3 halves. Okay, so rise over run. Going to go up 3, 1, 2, 3. Run right 2, because it's positive, 1, 2. Put a point. I could do that again. 1, 2, 3 up, 1, 2 over. Now here's where I talked about sometimes writing the slope in an interesting way. This is also -3 over -2, right? Because we can simplify from -3 over -2 to 3 over 2. 2 negatives divided make a positive. 2 positives divided are the same as 2 negatives divided. So why is that useful? Well, let's start here again. -3 tells me fall down 3 and go left 2. Fall down 3, go left 2. So now I have a whole bunch of points. They all fall on the same line, so I'm convinced that I either did this right or messed up very, very consistently. And it matches up with the others, the other one too. So all very good signs. I'm going to put my arrows here. And I've just graphed it with method 2. So I just figured out the y-intercept, used the slope to move, and I wrote the slope in kind of a funny way to allow me to have a little more flexibility. Method 3. That's finding the intercepts. So y-intercept, y equals 1.5. I'm going to plug in 0 for x. And I guess it's bolder, that works, which is 0. So I have the point 0, 0 as my y-intercept. My x-intercept, I have 0, because that's what I'm plugging in for y now, equals 1.5x. I want x by itself, so I will divide by that 1.5. Could have turned it into fractions and done it that way too. Either way, we get x equals 0. So we have the point 0, 0. Same one. Now that's a problem. It's good that they line up if they're on the origin, because if one's on the origin, the other had better be. But we only have 1 point, right? I plot my 0, 0 and my 0, 0. They're right on top of each other. There are infinitely many lines that go through that point. This one, this one, this one, this one. I don't know which to pick. So the only thing that I can do from here is either throw my hands in the air and just give up, or I can kind of go back to a different method, say method 2 and use my slope, or method 1 and use my, my table. So once we've gotten to here, we know it goes through here. We don't have enough information. We would need to use something else like the slope to tell us how to graph it. So if we're using the slope, so this is, we went back to method 2. The slope is 3/2. And so we'll do the same thing that we did over here. And I will let you finish that off. Let's start out number 2 together. And we'll start with our 4-column chart. So we have X, the equation, Y, and XY. Okay. I get to choose my X. I'm going to start with, this is kind of a tricky one. So we've got fractions all over the place. 0 is pretty easy though. Let's start with 0. So I have Y equals 3/4 times 0, plug in 0 for X, minus 5/2. And that's just negative 5/2. So the point 0, negative 5/2 is on my graph. Okay. So 0, negative 5/2. Let's actually turn that into something that we like a little better. We'll call that a mixed number. So 2 goes into 5 twice. We have negative 2, there's one left over, negative 2.5. Don't go over at all. Go down 2.5. Point there. Let's try 4. I like using 4 because I tend to use a multiple of the denominator of the slope. The reason I do that is because if I have a 4 on top and a 4 on the bottom, those cancel out. I'll be left with whole numbers. Now I still have this 5/2 to work with. So we could even take it one step further and think ahead about that. But I think I'm just going to go with the 4. So I have Y equals 3/4 times 4, which is 4/1, minus 5/2. 3/4 times 4/1, so that's just 3. We can write that on a second line, minus, and we turned that into 2.5. What's 3 minus 2.5? Back taking a whole number minus a mixed number. Well, there's just 1/2 left. Oops. So my point is 4, 1/2. Over 4, up 1/2. Now, about, let's see, I was thinking 8, but that's not on my graph, so I won't even bother trying. Let's go with the negative 4. Negative 4, so Y equals 3/4 times negative 4/1 minus, we'll call it 2.5 because we established that those are the same thing. The 4's cancel, I'm left with negative 3. So it was negative, minus 2.5. Negative 3 minus 2.5, so negative 3 minus some more. I'm adding 3 and 2.5 to get 5.5 and using the sign that they both share of negative. Negative 5.5. So my point is negative 4, negative 5.5. Negative 4, negative 5.5. Notice that if I had used 2, negative 2, 6, or negative 6, well, actually, I'll tell you what, try it out. Try one more point, either 2, negative 2, 6, or negative 6, and see what happens. See how nicely or not nicely it works out. So go ahead, pause the video or make a note to complete that later. And let's talk about method 2. So this was method 1. Whoops. Method 1. Method 2, I'm going to find the Y-intercept. We do that just by plugging in 0 for x, because if x is 0, if we're not going over at all, we know exactly how high up to go. So we take that equation, plug in 0 for x. Notice it looks the same as the first step on method 1. That's another nice thing that I like to use 0 for, because then I've got some double checking going on. So we'll find our y-intercept, we'll find our slope, which is in front of the x. So m is 3/4, already a fraction for us, so that's nice. Remember also, if they're both positive, that's the same as them being both negative. So this helps you go in either direction. I'll let you finish that one up. And then method 3, this time we actually can use it all the way. So our y-intercept, we plug in x equals 0. You've done that over here by now, or you will soon. Our x-intercept, you plug in y equals 0. That takes a little more work, so let's show that one. Okay, so 0 equals 3/4 x minus 5/2. Okay. I have just a single variable, so let's get that variable by itself. Remember, reverse order of operations, I'm going to add 5/2. I'm going to keep it as 5/2 because I've got fractions here. So 5/2 equals 3/4 x. Now I need to divide by 3/4, or equivalently, multiply by the reciprocal. So if I multiply this by 4/3, I'll get 12/12, or 1. I have to do the same thing on this side. That's okay. So now I'll split my sides. Since there's no inequality sign, I can do that without having to worry. X equals 20/6, or 10/3, which is, as a mixed number, 3⅓. So my x-intercept, is it 0, 3⅓, or 3⅓, 0? Take a minute to think about that. I want it on the x-intercept, or the x-axis, excuse me. So I'll run over, but not up or down. So this is 3⅓, 0. 3⅓, without going up or down at all. You'll plot your y-intercept and you'll connect those 2 points. Okay. For number 3, we have something that's so easy it's hard. Well, not really hard, but it's a little surprising at first. Y equals -3. Feel free to give that a shot. If you'd like a hint, I'll give one now. What if we wrote it that way? All right, that's the same equation because 0 times x, it doesn't matter what x is, that's always 0. So that can help you as you work through methods 1, 2, and 3 here. And then, oops. For 4, we have y equals -2x plus 1. The slope is -2. How do I write that as a fraction? Well, give you a sneak peek for the slope over here. -2/1, right? I can do that. Or 2/-1. In this class, I've been saying sometimes we want the negative in the denominator. Here's an example where we might, because this is saying either drop 2 and go right 1, or rise 2 and go left 1. Okay. Once you have tried the methods for all of these, and I'll tell you again, there's one more where method 3 doesn't quite work. We have to use some additional information. Take a look at pages 117 through 119.